Hello everyone. I hope all of you are doing fine. I feel honored to be here at CityJS Conf, and it is so incredible to be speaking to all of you through this wonderful platform. Welcome to my presentation on implementing AI in your site using TensorFlow.js. JS. But before that, a quick introduction about myself. So, hi, my name is Pratham Prasoon. I'm a 16-year-old high school sophomore student, and I'm into Python, JavaScript, and Flutter, with specific interest in data science, machine learning, and app design. You can find me on Twitter at Pratham Prasoon. Let's connect over there as well. So, before we get into the presentation further, I would like to inform you that AI and machine learning are slightly different terms, but for the purposes of this conference, I'll use them interchangeably. Just know that AI is generally a wider term than machine learning. Moving on, why should you know about TensorFlow.js? So when TensorFlow was first released for Python in 2015, it had a lot of limitations, and it was not really accessible to many of the developers out there, and it required very specific kind of hardware to be able to use TensorFlow properly. But TensorFlow.js changed that when it was announced in 2017. So it was made keeping in mind that it has to be friendly for web developers. And since it's made, you can use JavaScript, that means that you don't need to learn another language to get into this exciting field of AI. And you could learn TensorFlow.js maybe for a career switch, or maybe you just want to learn something cool. And it is always good to have extra skills, right? So in 2015, we just had TensorFlow, and then we got TensorFlow.js. The benefits of TensorFlow.js are that, one, you can build privacy friendly applications. So typically when you're training AI models, you have to take the data back from the client and then process it and then give it back to the client. But TensorFlow.js totally changes this. You do not need to get the data to you and then give it back to the user. Instead, you could simply process the data inside the browser without any fancy GPUs or that sort of thing. And it can work on basically any device with a network connection and a browser on it. You could all, if you don't want to train your own AI models, you could simply use pre-trained models from the internet and then implement them in your site. So it really makes the process of implementing AI a piece of cake, honestly. Um, now, before we go on to the code and the technical stuff, let's understand what AI is in practical terms. So, AI in most cases is giving loads of data to the computer. Those could be images, voice samples, it could be text, it could be anything. And then the AI learns from that through trial and error. So, I'll give you an example right now, which will hopefully make you'll get a better understanding of AI with that. So let's say we have Jack over here. He's a kid. He doesn't know a lot about the world. So we try to teach him about dogs and cats. So what is a dog? What does a dog look like, and what does a cat look like? So what we do is we take two stacks of photos, one with cats and one with dogs. We know we have sorted them out ourselves, and then what we do is we give the images to Jack, and we tell him, hey, look, this is a cat. So remember that this is a cat. And then we show him photos of a dog, so maybe he can remember what dogs look like. So maybe you could see the features like cats usually have a longer tail than dogs. Maybe I'm just giving an example here. Maybe they have sharper ears, maybe they have lighter eyes. So these are the kind of features which he will remember in order to identify a cat and a dog. So that process, like he processed that information inside his brain. So then after he has learned what a cat and a dog looks like, we scramble all the images and then we randomly pick images out, and then we show it to Jack and ask him, what is this? So maybe he answers this right, he says it's a dog, maybe. And then we show him a picture of a cat and maybe he answers that right too. but he could make mistakes along the way, right? So let's say out of we gave him 10 photos to test, and out of those 10 photos he was able to identify 8 correctly. So he had a 80% accuracy. Now we'll replace Jack with AI. The same process happens here. We have pictures of cats on one side and dogs on the other side, and then we scramble it, and then we test it out on the AI, and then we give it an accuracy score. So both, I hope this kind of solidified your understanding about AI. Moving ahead, so this the process that we just saw, wherein we already have sorted out data, and then we give it to the AI to learn from it, and then we test out how much the AI has learned. This sort of learning is called supervised learning. Now a similar method to this is called unsupervised learning, wherein you do not sort the, like how we kept the two images, to the images of dogs and cats separate. We do not have that step. We basically just give the AI scrambled images, and then it sorts the images on itself. It might make mistakes along the way, but everybody does make mistakes. So, and eventually it does increase the accuracy by learning again and again. So this is a slightly different way of learning, but um, the fundamentals remain the same. You give data, and then you get an output. It predicts some sort of output, and we give it an accuracy score. How many images did it identify correctly, and how many it did not? And then the third kind of AI is called reinforcement learning. This is a very interesting kind of AI in the sense that this AI exactly replicates how humans learn. So there is no data whatsoever given to the AI. The AI collects the data itself, and then it learns from the environment. So this is mostly used in games. So you could have, let's say, an AI for maybe driving around some path. So maybe it learns through it, gathers data when it moves, and then it learns from its environment. It knows, and then it realizes what to do and what not to do. So this is a very interesting kind of AI. But today we'll only be focusing on supervised learning for image classification. So we'll build this handwritten digit recognizer, and you can try it out for yourself at this link, bit.ly/tfjs demo. So basically what you can do is you can draw a handwritten digit, and then you can predict it. So the AI will predict what number you have drawn over here for you. Now, we'll be using. Remember how I said that when we were teaching Jack how to differentiate between dogs and cats. Here also we'll be using a data set. So we'll have 70,000 images of handwritten digits, and this is called the MNIST data set. So we'll be using this to train our AI model, as well as use it for the predictions and testing it. So we'll get into that as well. So these images are 28 by 28 images. So the resolution is 28 pixels by 28 pixels. And then what we'll do is we'll convert this into an array, a list of numbers, my bad. So we'll convert it into a list of numbers depending on what color the pixel is. So let's say the top left corner of the pixel is white, so we give it 255. And then where we get a black pixel, we give it 0. So we get a huge list of around 764 numbers. So those are the amount of pixels that are in these images. So to train our AI model, we will use this thing called a neural net. So basically, what a neural net is, it takes input from the data. So let's say we have in the input of the color of the pixels, and then we put them here in this sort of fashion. So we'll have 764 inputs here, and then what will the computer will have. So this is called the input layer, and after that we'll also have an hidden layer. As you can see, there are lines which connect the input layer to the hidden layer. So what happens in that process is the computer does some calculations to it. It does some maths to it, and it sort of consider it like a function, and then it gets some numerical values, and then those values correspond to the output layer. So in the input we'll have 764 inputs. We'll have 764 pixels. So we are basically putting that in the input layer, and then in the hidden layer we'll basically let the AI do the learning and those sort of things. And in the output layer we'll have 10 outputs, numbers from 0 to 9, because remember that is the data set we actually gave to our AI, 0 to 9, right? So those are 10 digits. So this is a very good image. In fact, it explains the concept which I just said brilliantly. So as you can see, where we have black pixels, it's 0, and where there is some color, it's like some shade of gray, then there's a number. So basically you're converting the pixels into this long stretch, a list, you could say. And then we're feeding those numbers into the input layer of the neural network, and then the hidden layer figures out things on its own. I mean, there is some math involved in it, but for now we'll not go into it. Now let's look at the code, because that is the interesting part here. So um, uh, let's look at the code. So I have just close that. Yeah. So this is I've opened VS Code over here, and if you can see, this is the file structure over here that we have. So we have one Python file, we have a models folder, and we have a JS folder. I'll explain one by one what these mean. So the style is, it basically contains styling for the website, nothing special here. Index.html, we have the MNIST.py, which is where we actually train the model. Now I have used Python over here because I feel I feel more comfortable with Python, but I definitely encourage you to recreate this AI training process inside JavaScript. It will be really good practice. So and then we have the models folder where the model is actually stored, and then we have the JS folder where we have chart.js, which is basically a library for charting um, the prediction. I'll let you know what that is. And then we have recognition, which basically is a JS file for knowing how to draw, for drawing the shapes to give as input. So, but the main file that you have to take a look at is this folder. So if you know JavaScript pretty well, this is not going to be very difficult. Python is it's a pretty easy language to get on with, but yeah. So first thing we do is we import the libraries. So we have TensorFlow.js. We have Keras. Keras is a library that goes in conjunction with TensorFlow, so you don't need to worry about that. And then here we load the data. So the MNIST dataset, which has all the numbers, the handwritten numbers, is already preloaded into the Keras library. So we will load that, and then what we'll do is we will separate the training images, wherein remember the process where we showed Jack the pictures, and so at the start, so that he could learn. So those are the training images and the training labels. Labels mean is like, let's say you have a picture of one, so the label should be one, as in the name of the file should be one, right? um, so and then we'll have the test images, wherein we actually test how good the AI is doing. So we load that data over here, and then we group the data. So we have 70,000 images. Out of those, we are putting 60,000 of those for training the data, and then 10,000 for testing the AI. And then we normalize the images. So basically, neural nets perform much better when the values are between from 0 to 1, instead of it being from 0 to 255. So dividing all the values by 255, basically it allows for better training of the AI. Continuing on, this is the main part. This is the thing that actually um, this is the thing that runs the entire thing, the entire AI itself. So we are using a model here. This is a machine learning model. So we have this is the first layer. This is the input layer. These three combine to be the input layer. as I mentioned before, and this is the hidden layer, and this is the output layer. So I'll explain one by one what this means. So this these three layers basically do this thing called a convolution, which basically means that it sort of sharpens the images, so that you can basically you can basically have a sharper image, and the computer can better look at the details in the image. And then we have the dense layer, which is the hidden layer, where the computer figures out things on its own. And then we have the output layer. Notice we have 10 as the output, because we'll have predictions from 0 to 9, right? And in the input we have 28 by 28, so the resolution is 28 by 28, and a depth of 1, meaning it's one dimensional. Nothing to worry about there, but yeah. And then what we do is we compile the model using these metrics over here. We will not go into detail on these, but feel free to explore for yourself. And then so this is where we actually train the model, as in we tell the model what does a zero look like, what does a one look like, and then we test the data, test the AI. So and then we basically do this process, and then we get an AI model that can predict stuff. Now we will save this into this model into the models folder, and then it gets stored over here. Simple as that. And then we basically have the JS library for charting, and then we have the digit recognizer, nothing special here. Then we have the index HTML and CSS, also nothing special, really special over there. Now let's go on to the site. So this is what the end result looks like. So what you can do is you can draw numbers over here, and you can click on predict and see. So it is 99% confident that this is a 2. So that's pretty good. We could draw other shapes to numbers to this is a 1, right? It does that pretty well. It does fail sometimes, like see over here. You could improve the model. In fact, I would encourage you to do that. Sometimes it does do mistakes, but it's generally pretty accurate. So that's a 9. So maybe we drew it a little bit higher. But yeah, you can definitely this is you can definitely improve the model. But this is just to show that you can basically run AI in your browser, which is pretty incredible. And keep in mind that none of the data is actually leaving the browser itself. It is all contained into this into the browser itself. In fact, if you want to try a live demo for this, you can go to tf.js pfjs MNIST.Vercel app, and there I've deployed the application on Vercel. So there you can see a live version of this as well, and you can try this on your phone or try it anywhere. It will run inside the browser perfectly fine. Now, now that we're coming towards the end of the presentation, let us look at some further resources to get started with AI. So these are the three courses or which I would recommend. So one is from Kaggle. Kaggle is a very well-known. It's the basically the hub of data science, and there are lots of challenges you could do. It's a pretty incredible place. And then you can use the Google the video series by Google on machine learning foundations, which is also a pretty incredible, very incredible course. And then we also have the famous machine learning courses by Andrew Ng. So I really hope you got something useful out of this talk, this presentation, and I really hope you enjoy TensorFlow.js. Do tinker around, play with stuff, make incredible things. The sky is the limit here. So yeah, I really hope I could provide some value here today, and thank you so much for attending this talk. Thank you.
Hey Pratham, how are you doing? That was an amazing talk. Well done.
Thank you so much. I really enjoyed it. This was my first ever talk, and I really enjoyed the process. of
wow.
making the video, and
First
yeah,
ever talk. You came across like a pro. I know seasoned pros who have melted under the pressure of having to do a remote talk. So well done for that, as well as
thank you
an
so much,
amazing
man.
talk. I certainly learned a lot about TensorFlow.
Mhm.
So the questions are coming in quick and fast already. So should we get cracking
Okay,
with them? So
yeah, sure.
actually, it's the felt ones from the previous session that are
Yeah.
still there. But we have had one come in. How do you train the data set? Not the code, but the tool to process it. Do you know anything about that you could mention?
So how do you train the data set? So you essentially use this thing called a neural net, which tries to replicate how the human mind works. So like you might know that the human mind has neurons. So we use a neural net to train the data set. So like in fact, I mentioned in the video that we essentially convert the image into a long array. So that is the sort of data which we can actually give to the neural net, and then the neural net can learn things and then give you predictions about it. Yeah,
Okay.
that is a short explanation on how it works.
Okay, so that sounds like we should go back and watch your talk again and refresh our memories about it, maybe.
Yeah, for sure.
How do you decide on the size of the hidden layer?
So it really depends on the data set. In most cases, uh, having around 100 to 512 neurons in the hidden layer does the job well, unless you're working on a really big data set. So, like let's say companies like if Spotify were to use TensorFlow.js, they would have to make a really huge neural net because the amount of data is just there's just too much data over there.
Yeah.
But for most purposes, around 100 neurons in the hidden layer work perfectly fine.
Okay, so that's a lot of neurons. How does that compare to a human brain in terms of how we process that
Uh,
information? I
it
don't know.
does not compare well to human brain, of course. We have trillions and trillions of neurons in a brain, but and there's only so much that a computer can do, right?
Hmm.
So yeah, it's not really comparable.
Do you think we'll get to a point when it will be comparable?
Yes, of course. In fact, now we just like you might have heard about GPT-3.
Yes.
So Elon Musk's company Neuralink is working on training um, a big neural net, which uh, like they're basically trying to train a neural net that can do multiple things. It could do image recognition, speech recognition. It could. They basically want it to be as good as a human. So
Yeah.
yeah.
Oh, wow. Well, I suppose that's where Neuralink comes in. So he can extract or use, maybe he's creating a neural net of people to do his processing on.
Yeah, maybe.
I hope not. I really hope not. So we've got a couple more questions come in. One of the cool things about TensorFlow.js is that it can be used in browser. But are there any times when you shouldn't and should, in fact, move processing to a backend?
So there is a limit to how much data you can process in your browser. But I mean, the whole point of TensorFlow.js is basically to integrate AI inside the browser in a small package such that it actually runs on any device you can imagine with a browser and an internet connection. Um, but if you're working on research or something like that, or for academic purposes, it is not really advisable to run AI models in the browser because I mean that's not the purpose of TensorFlow.js. So like the core purpose of TensorFlow.js is to bring the world of AI for web developers. That is why it is written in JavaScript, and and it's in my opinion it's not that tough to get into. It's not as tough as people claim it to be. Yeah.
Okay. And why do you think people do claim it to be quite tough to get into. It's an intimidating subject to come in fresh to, but is there anything more than that?
So the um the thing is, for a long period of time, like AI and these sort of things were they were basically just um they were restricted to, like, scientists and for research purposes. It wasn't really available for the general public. So and in the recent years, what has happened is that AI has become this buzzword, and that sort of and when people think about AI, they find it to be very very intimidating to get into. But that's certainly not true. I would go as far as to say that getting into TensorFlow.js is as easy as learning a new JavaScript framework like React or Vue. It's just that you have to get used to a few terminologies here and there. And another thing, people think that to get into AI, you have to be really good at math, which is certainly not true. Because you can do a lot with AI without knowing any of the math that is going behind it. So yeah, that's my take on it.
I suppose the point of it is to abstract us away from that mathematics. We may have trillions of
Right.
neurons, but a computer maybe is better at presenting the information than our brains are. Okay, that was a brilliant answer. Thank you. We've got another question come in. How do you tell the software that the prediction was incorrect?
So we do not tell. So reinforcement learning, that is where you can actually where the AI actually gets to know that it has done something wrong. But in the kind of learning which we have developed, the digit recognizer, um, uh, the only time when it knows that something is wrong is when you're training the data set using the neural net. So basically, the images have labels, right? And while testing the neural net, like when it is testing itself, if it let's see, you it gets a picture of 1 and it incorrectly predicts that as 7, so then it gets to know that it is wrong, right? So and then it sort of goes back again and looks at what went wrong. I mean, there is some math involved in it again. I'm trying to boil things
Of
down to
course,
a
of
simple
course.
level. So that is how it works.
Okay.
Kind of like how humans learn, like through trial and error, right? If you look at small kids, if they do something wrong, their parents probably get mad at them, and then they do not do it again.
Does
So
that mean
it's a trial and error process.
Does that mean you give TensorFlow a smack if it's been naughty and getting things wrong?
Yeah,
No,
I mean,
nobody should
yeah,
be
that's a good.
smacking their kids. I'm just going to say that there. We do have another question come in. Do you have any recommendations for good AI JavaScript resources? Maybe that's related to TensorFlow JS. Maybe it's a more broad, broad article about the topic. Got any recommendations?
So the general training process and the code syntax is very similar between Python and JavaScript. That is one of the good things about TensorFlow.js. Um, but you do get the perks of JavaScript, like you can have asynchronous functions and those kind of things. But good learning resources. So at the end of the slide, I'd given 3 learning resources. One was from Kaggle, which is basically the hub for data science, and then we also had the machine learning fundamentals course by Google, who they created TensorFlow itself. So that is also a very good course. And then you have the famous machine learning courses from Andrew Ng. So these,
Oh dear.
yeah,
You're back. I thought we'd lost you for a
yeah,
moment
sorry,
then. Yeah, so
yeah.
you're just saying you've put the resources at the end of your slides are probably where you'd
Yeah,
recommend
I can
people
share the
start with
slide if
that.
you would like, if you like that.
Yeah, if you put it into this chat, if you've got it there.
Yeah, for sure.
So while you're doing that, I've got to ask you, why have you got your books organized in that way? I've never
Um,
seen I've never seen a bookcase arranged like that before.
so this bookshelf was designed by my dad. I mean, he's he's fond of design and architecture and that sort of thing. So um, so when this house was actually in construction, he thought, why not do something different than the previous house, right? So yeah, we have this sort of. It's an interesting design. Yeah.
It is. It's just weird. Does your dad take orders and does he ship to the United Kingdom?
Oh no, he's not an architect by profession, but I mean,
Ah,
if you want, we can help out for sure.
okay. Back to the JavaScript, I guess. Can I use TensorFlow JS for learning AI instead of using Python because I'm from a
Of
JavaScript
course you can.
world?
Of course you can. That was the sole purpose of TensorFlow.js, making it accessible to web developers who know JavaScript, right? So um, the entire thing which was shown in the presentation can be done purely in JavaScript. In fact, there's a very good YouTube video by fireship.io. I think I'll drop that link here as well. So over there, he uses uh, Angular along with TensorFlow.js to make the entire model inside JavaScript, and it certainly can be done. In fact, I mentioned about keras in the presentation. Now Google just launched a new library called danfo.js. I'm not quite sure on the name, but that is essentially a keras replacement for Java. Like, it is written in JavaScript. So Google is encouraging web developers out there to try out AI and these sort of things in JavaScript. So I think it's a
Huh?
growing community, and you should definitely take a look at it. Yeah.
Yeah, I mean, you've inspired me to dive into this kind of stuff. I think I'm going to train something to detect whether a photo is of my cat or not. So that
Yeah,
seems to
for
be the best thing for this. It was the example you used, right? Cats and dogs.
yep. And
And
if you
so
get stuck, you can always ask me. Yeah.
Oh, perfect, perfect. So we've had another question, which I think you answered in the previous one, but I'll reiterate it anyway. Can the models be trained using JS and JS alone?
Yes, they can. In fact, Google is constantly trying to support like web developers get into the field of AI. So a lot of the tools that were originally written for Python are now being available on JavaScript as well. So I mentioned about danfo.js, which is basically a keras replacement, what I showed in the video in the presentation. So yes, you can definitely do it.
Okay.
What other? Yeah,
Sorry, you're going to carry on, carry on.
yeah. So I was just reading a question here. What other projects have you made using TensorFlow.js? I would consider myself more as like a Python developer first. So I very I've very recently like started learning JavaScript like 5 6 months ago. So do not have many projects in TensorFlow.js, but Google itself has a really good catalog of projects that you can build. In fact, they have this game that runs inside the browser, where you basically have video detection, and it basically asks you like it will ask you to bring a book near it, and then it will ask you to show the book to the camera. So it's kind of like find things around the house. So then it could ask, show me a picture of a fork. So within 60 seconds, you have to run back, get the fork, and show it to the camera, and then it detects it. It's a pretty cool game.
Yeah, that sounds fun. It sounds like one which involves a lot of exercise, which
Yeah,
normally
definitely.
eliminates it as a game of choice for me, but it does sound fun. So, what
I'll
are
just
you
yeah.
working on then? What's your next little side project? Doesn't necessarily have to be JavaScript, but are you building
Mhm.
something cool in Python at the moment?
Yes, I am. So I'm working on an application which will be made using Flutter and Python, Django to be precise, Django REST framework. So yeah, it's an app in the works. So It's a bit of a different idea to like some of the projects I've done. So it's like recreating the stock market. I mean, it's not really related to TensorFlow.js in any way, so I won't go too much into detail on that.
No, you don't want to give away your trade secrets.
Yeah,
So
for sure.
the next talk's going to start very shortly. So I'm going to draw this to a close and say a huge thank you for being a part of the 2020 CityJS conference. Your talk was absolutely amazing. It's inspired me to go and look into TensorFlow, and I'm sure it has for others. And I look forward to seeing your other talks in the
Thank you so
future.
much. It was an honor being here. Thank you so much. Yeah.
Cool. Look forward to seeing you in the chat area for the rest of the day. Okay, so we'll be heading back into the conference talks very, very shortly. So we'll see you in the chat or in YouTube. Cheers, Pratham.